Welcome to the deep dive.
Look, you've got a lot of information coming at you, right? And you're here because you want to cut through the noise, figure out what really matters, and do it fast. Today, we're diving into something pretty central to getting useful stuff from AI prompt engineering for large language models, LLMs. You've probably heard of models like Gemini.
That's right. Yeah, think of this as your guide to getting more bang for your buck with these tools. We're moving beyond just typing in a quick question. We're going to show you how to really craft prompts, prompts that dig into your sources and pull out the genuinely meaningful insights.
Okay, prompt engineering sounds maybe a little technical, but really it's just about being smart, being strategic in how we talk to these AI models. Anyone can type something, but the real skill, like we'll explore, is writing the prompts that get you accurate, insightful answers, guiding the AI. And well, like anything, it takes a bit of fiddling, doesn't it? Absolutely. It's kind of like chatting with a super smart research assistant. Sometimes you got to rephrase things, right? Ask the question differently to get the best answer. LLMs. Same deal. You tweak your prompts, refine them to get clearer, more targeted output from whatever information you're working with. And believe me, a good prompt makes a huge difference. Vague answer versus real breakthrough.
Now, something that jumped out from the material you sent over was this focus on interacting directly with the models, like using Gemini through Vertex AI or maybe an API. Why is that direct link so important here?
Yeah, that direct access. It gives you a layer of control that's just, well, crucial. It lets you get under the hood, tweak the engine settings, things like temperature, for example. That influences how creative or, how focused the responses are. Being able to configure the model's behavior along with crafting the right prompt, that's where the real power is. That's how you really get the most out of your sources.
Okay, so what's the game plan for this deep dive then? What are we going to cover to help us become savvy prompt engineers ready to tackle our own info overload?
Right. So first, we need to get a handle on the basics, how these language models actually work, because knowing that really shapes how we should prompt them. Then we'll jump into a whole range of really effective prompting techniques. Practical examples you can use right away on your own stuff. We'll also look at adjusting those LLM output settings, getting exactly what you need. And then, wrap up with some key best practices to guide you.
Sounds like a solid toolkit.
Yeah.
Okay, let's start with those basics. How do these LLMs actually function? Why is prompt engineering such a key piece of the puzzle?
Okay, so think of LLMs as really, really advanced prediction machines. Seriously advanced. They've been trained on just massive amounts of text data. And their main job, it's predicting the next token in a sequence. A token could be a whole word, maybe just part of a word, even punctuation sometimes. So when you feed it a prompt, it looks at that sequence and tries to figure out, based on all the patterns it learned during training, what's the most probable next token.
Okay, right. So prompt engineering then is basically crafting our input, the prompt, so it strongly nudges the LLM to predict the specific tokens, the specific sequence that gives us the answer or output we're actually looking for, setting it up for success, kind of.
Exactly that. And the sheer range of things you can do with well-engineered prompts, it's honestly pretty impressive. Your sources probably mention things like summarizing long documents down to the core ideas, right? Or pulling out specific data points from really dense text, getting direct answers to questions, sorting different kinds of text, translating languages, even code, generating new code snippets, or helping you figure out what existing code does.
Wow, that really is like a Swiss Army knife of capabilities. Now, I did notice a point about choosing the right model. Does it actually matter much if we're using, say, Gemini versus, I don't know, some other model? Do we need different prompts?
Oh, absolutely. Yeah, it matters. Different LLMs, they have different architectures, they're trained on different data, so they naturally have different strengths, maybe different weaknesses. They might respond quite differently to the exact same prompt. While the basic ideas of good prompting generally apply, you'll likely find you need to fine-tune your prompts a bit. Tailor them to get the best out of a specific model, whether that's Gemini, GPT, Claude, or maybe even an open source one like Gemma or Llama. It's not really a one-size-fits-all deal.
Okay. Tailoring the approach, depending on who we're talking to, makes sense. And you mentioned earlier we can control more than just the words in the prompt itself. These other controls, what are they?
Yes, exactly. This is where understanding the LLM's output configuration really comes into its own. Beyond just the prompt's language, most LLMs give you settings that directly shape the output text. Learning to use these settings, that's a key part of getting precisely what you need from your sources.
All right, let's start with one that sounds simple enough. Output length. How does tweaking that help us?
Output length, yeah. It usually means the maximum number of tokens the model will generate for its response. It's worth keeping an eye on because, well, more tokens mean more computation, which means potentially longer waits for the answer and maybe higher costs if you're using like a paid API.
Okay, so if I just dial down the output length, does that automatically make the answer shorter and, more concise?
Not necessarily, no. Reducing the output length just tells the model, okay, stop generating tokens once you hit this number. It doesn't automatically make the language itself more succinct. If you need a really brief answer, you'll probably need to craft your prompt to ask for brevity, as well as setting a sensible output length.
Interesting distinction. And I saw a note that limiting the output length is especially useful for techniques like React. We'll get to React later, but why is it important there?
Ah, React, right. With React, the LLM kind of loops through reasoning and then taking actions, like searching online. If you don't cap the output length, the model might just keep generating tokens even after it's found the answer, maybe adding extra fluff, getting sidetracked.
Got it. Okay, now on to something called sampling controls. Sounds a bit more technical this time.
It is a bit more nuanced, yeah. But it's really key to understanding why LLMs can sometimes give you different answers even if you ask the exact same question. See, when an LLM generates text, it doesn't just pick the one most likely next word. It actually calculates probabilities for all the possible words it knows. Sampling controls things like temperature, top K, and top P. They influence how the model chooses from those probabilistic options to build its response.
Okay, so it's about adding a bit of controlled randomness or predictability into the word choices. Let's start with temperature. What's that controlling?
Temperature, right. It basically dials up or down the randomness in the output. Lower temperature, closer to 0, makes the model more deterministic. It'll consistently stick to the words its training data says are most probable. Really useful when you need factual, predictable stuff from your sources. Highly focused. A temperature of 0 is often called greedy decoding, always grabbing the top probability option, though there's a small detail about tie-breaking if multiple tokens have the exact same top probability.
Okay, lower temp equals predictable. What if we crank it up?
Higher temperatures, that injects more randomness. The model gets more willing to pick words that, according to its training, have lower probabilities. This can lead to more diverse output, maybe more surprising, potentially more creative stuff. But the flip side is if you push it too high, the response might become less coherent, maybe even nonsensical. It's a trade-off, predictability versus creativity.
Makes total sense. Low for facts, high for maybe brainstorming or creative writing. Now, what about top K and top E?
Right, top K and top P. There are two other ways to control the output by basically narrowing down the list of potential next words, again, based on their probabilities.
Okay, let's tackle top K first.
Top K sampling. Pretty straightforward. You set a number, K. The model then only considers the top K most likely next tokens. So if K is 10, it only looks at the 10 words with the highest probability. A bigger K gives the model more options, maybe more creativity. A smaller K makes it more focused, more factual. And if you set K to 1, that's basically the same as temperature 0 greedy decoding again.
And how is top P, or nucleus sampling, different?
Top P works a bit differently, yeah. Instead of a fixed number of tokens, like top K, it looks at the probabilities themselves. You set a probability threshold, P, somewhere between 0 and 1. The model then picks the smallest group of top tokens whose probabilities add up to at least P. So if P is 0.9, it keeps adding the most likely tokens until their combined probability hits 90% or just over. It focuses on the core nucleus of probable options.
Okay. So top K is a fixed count of options. Top P is reaching a probability sum. Is one generally better than the other?
Not really, no. It often just boils down to experimenting. Seeing which one, or maybe even using both together, gives you the best results for whatever specific task you're working on with your sources.
Now, how do these all work together? Temperature, top K, top P? Sounds like they could get tangled up.
They definitely interact, yeah. It helps to know the typical order they're applied in. Like in Vertex Studio, if you set values for all three, the model usually first figures out which tokens satisfy both the top K and top P conditions. From that smaller pool of candidates, the temperature setting then influences the final pick. If you only have, say, top K available or only top P, then just that filter gets applied before it makes a choice, assuming temperature isn't also set, of course.
What if we push one of these settings to an extreme? Could it just cancel out the others?
Oh, totally. Yeah. For instance, set temperature to 0. It's always picking the single top token. Top K and top P become pretty much irrelevant then, because there's zero randomness. Or crank the temperature super high, then the temperature itself has less impact, and the choice is mostly driven by whatever tokens got through the top K or top P filters. Setting top K to 1 also forces that single top choice. On the other hand, a really high top K, or setting top P to 1, includes almost everything. And setting top P near 0, that likely just picks the single best one too.
So it's definitely a balancing act to get the settings right for what we want. The material gives some general starting points, right? Depending on if we want coherent, creative, or factual results.
Yeah, some useful guidelines. If you want something coherent but still kind of creative, maybe try temperature around 0.2, top P at 0.95, top K around 30. For really creative stuff, maybe push the temp up to 0.9, top P 0.9, top K 40. Need less creativity, more focus. Try temp down at 0.1, top P 0.9, top K maybe 20. And for tasks with really just one right answer, like math, starting with temperature 0 is usually the way to go.
Okay, that gives us a framework to start experimenting. But there's a catch, isn't there? A warning about giving the model too much freedom.
That's right. Yeah, if you go too high with temperature, top K, top P, and allow a really long output, you increase the risk that the generated text just wanders off topic, becomes less relevant to your prompt, less relevant to your sources.
And there's also this thing called the repetition loop bug. That sounds bad.
It is, yeah. Definitely something to watch out for. The model just gets stuck repeating the same word or phrase over and over, sometimes with filler words. And the weird thing is, it can happen at both low and high temperatures, low temps. It might lock on to one highly probable sequence and just repeat it, high temps. The randomness can sometimes loop it back to something it already said. So you really need to carefully balance temperature and top K, top P to find that sweet spot and avoid getting stuck in those loops.
Okay, valuable tip. Now we've got the fundamentals, we understand configuration. Let's get to the really exciting stuff, the specific prompting techniques we can use to pull out those relevant insights from our sources.
Absolutely. Yeah, there are quite a few clever strategies we can use to guide these models much more effectively. We'll start simple and build up.
First up, general prompting, or zero-shot prompting. What's the basic idea here?
Zero shot. It's the most basic approach, really. You just give the LLM a description of the task you want it to do, maybe some starting text, like a question about your sources, or the beginning of a summary, or just instructions. The key thing is, you don't give it any examples of the kind of output you want. You're asking it to do something based purely on its training, without seeing a specific example in the prompt itself.
Okay. Our material uses an example for classifying movie reviews. Can you walk us through that one?
Sure. The goal was simple. Label reviews as positive, neutral, or negative. They used Gemini Pro, set a low temperature, 0.1, because, no creativity needed for classification, and a really short token limit, just 5, aiming just for the label. The prompt was basically, classify movie reviews as positive, neutral, or negative. Review, is a disturbing study. Rest of review, I wish there were more movies like this masterpiece. Sentiment. And the output, positive, which is correct.
Right. And the source makes a point about using a table format to document these crumbs. Why is that so crucial?
Oh, yeah. Because getting the prompt right, it's rarely a one-shot deal. You'll probably try out, several versions before you land on one that consistently gives you what you need from your sources. So keeping your goal, the model, the settings, the exact prompt text, the output you got, it's essential. For tracking progress, understanding what works, what doesn't, and for reusing successful prompts later. We'll definitely hit this again in best practices.
Makes sense. In that zero-shot example, low temperature is logical for classification. Default top KP, so they weren't really a factor. But the material mentions words like disturbing and masterpiece, adding complexity. Why is that?
Well, because those words pull in different directions, sentiment-wise, right? Disturbing sounds negative, masterpiece sounds super positive. The model has to weigh those conflicting signals to figure out the overall feeling. It just shows that even in seemingly simple tasks, the nuances in language can make the model's job tricky.
Right, nuances matter. So what if that basic zero-shot prompt just isn't cutting it, not getting the insights we need?
That's exactly when you move on to one-shot and few-shot prompting. These techniques involve actually putting examples inside the prompts to guide the model.
Okay, one-shot versus few-shot. How are they different?
So a one-shot prompt, it includes just a single example. Here's an input, here's the kind of output I want. The idea is the model learns from that one demonstration and applies it to new inputs. Few-shot takes it a step further. You provide multiple examples. Maybe 3 to 5 usually works well, but it depends on the task complexity and the model itself. The goal with multiple examples is to show the model a clearer pattern or a consistent style that it should follow when it responds to your actual query.
Okay, one shot shows one instance, few shot shows a pattern. How do we figure out how many examples to use in a few shot prompt?
Good question. It depends on a few things. How complex is the task you're trying to do with your sources? How good and relevant are your examples? And critically, what's the model's input length limit? You can't stuff too much into the prompt. More complex tasks might need more examples to make the desired behavior really clear, but you have to stay within that input window. Generally, like I said, 3 to 5 really well-chosen examples is often a good starting point.
Can you give us a practical example of few shot?
Definitely. Table 2 in the material shows parsing pizza orders into JSON format. Again, Gemini Pro, low temperature, but this time a higher token limit, 250, because JSON can be longer. The prompt starts with the instruction: parse a customer's pizza order into valid JSON. Then it gives 2 full examples in order and its correct JSON output. Finally, it presents a new, trickier order. Now, I would like a large pizza with the first half cheese and mozzarella and the other tomato sauce, ham, and pineapple. And the model successfully generates the right JSON for that half and half order. It learned the structure from the examples.
That really shows how examples demonstrating the input-output relationship can guide the model. What makes a good example when we're doing this with our own info?
Quality is key. Your examples need to be directly relevant to what you want the model to do with your sources. Ideally, try to make them diverse too, cover different scenarios, maybe even edge cases you might hit in your material. And obviously, they need to be accurate and well-written. Any mistakes in your examples can just confuse the model and lead to weird results.
Okay, 0 shot, 1 shot, few shot covered. Now let's talk about system, contextual, and role prompting. These sound like ways to set a sort of framework or mindset for the LLM.
That's a really good way to put it, yeah. These techniques are all about giving different kinds of guidance to shape the responses more effectively.
Let's break them down. What's system prompting exactly?
System prompting gives high-level instructions. It sets the overall context and purpose for the whole interaction. It defines the fundamental job you want the model to do. For example, a system prompt might tell the model, "You are a helpful translator," or "You are a text classifier following these rules," or "Generate code in Python adhering to PP8 style." It sets the stage.
Okay, setting the stage. How's contextual prompting different then?
Contextual prompting is more about the specifics right now. It provides details or background info that's directly relevant to the particular question or task at hand. It helps the model grasp the nuances of this specific request about your sources and tailor the response. Think of it as giving the immediate context needed for the current query.
And role prompting.
Role prompting is literally assigning a persona. Act as a historian. Respond like a cheerful customer service agent. You are a character from this book in my sources. This pushes the model to adopt the knowledge, behavior, even the tone of voice associated with that role for consistency.
I can see how these might overlap a bit. Like assigning a role could also provide context.
Totally. Yeah, in real use, they often blend. You might have a system prompt setting the main task, a contextual one adding details from your sources, and a role prompt dictating the style. But understanding the main purpose of each system for the big picture, contextual for task specifics, role for voice, and style, gives you a clearer way to design prompts and mix and match them flexibly.
Okay, let's dig into system prompting a bit more.
Yeah.
The material had that example controlling the output format for the movie review classification.
Right. Table 3. Still classifying reviews, but the system prompt added, only return the label in uppercase. And even though they cranked the temperature up to 1, which usually adds randomness, the model still followed that instruction. It returned negative in all caps. It just shows how powerful system prompts are for enforcing specific output rules.
So great for controlling format, and the material mentioned using it for other things too, like specifying a programming language or getting structured output like JSON.
Exactly. Table 4 shows that. A system prompt tells the model to classify a review and return valid JSON, following a specific schema defining the fields and data types. This forces the output into a machine-readable format. Super useful if you need to process the extracted info further or feed it into another tool. System prompts are also good for setting guardrails, like be respectful and avoid harmful content.
Got it. Now, role prompting in more detail. We saw the travel guide briefly. How does giving it a role really shape the output?
Role prompting taps into that huge training data set. By telling it, act as a book editor, analyzing your text, or be a scientist explaining this concept, it pulls on the knowledge, the vocabulary, the style associated with those roles. This makes the output feel more relevant, more insightful, tailored to that specific perspective you asked for.
Table 5 had the Amsterdam Museum suggestions from a travel guide. What if you changed the role? Like to a geography teacher?
Yeah, like the material suggests, the suggestions would probably be quite different, right? The geography teacher might focus more on, I don't know, geological significance or historical context. The travel guide offers practical tourist tips. Defining that role gives the LLM a blueprint for tone, style, expertise. It really boosts the quality and relevance of the response to your prompts about your sources. Your material even lists different styles you can ask for: conversational, descriptive, humorous, inspirational. Table 6 shows asking for a humorous and inspirational style for a Manhattan guide, and the result is much more engaging.
Okay, and finally, contextual prompting. It just seems like giving context is always a good idea when asking about our information. Yeah.
Pretty much, yes. Giving specific background directly related to your query helps the model zero in faster and generate more accurate, relevant answers. Table 7 showed that with the blog article suggestions. By first saying, "My blog is about retro 80s arcade games," the prompt gives vital context. The suggestions are then perfectly themed. Without that, they'd probably be way too generic.
Okay, cover the essentials for setting the stage. System, role, context. Now for some more advanced strategies. Next is step-back prompting. Sounds like making it think harder.
Step back prompting, yeah, it's a neat technique. Aims to boost performance on complex questions. The idea is, first, ask the model a more general related question, then feed the answer to that question back into the prompt when you ask your original specific query.
So it's like, get the AI thinking broadly before zooming in on the details in our sources. Why does that extra step help?
The thinking is, by tackling the general question first, you nudge the LLM to activate relevant background knowledge, maybe tap into reasoning processes it wouldn't have used otherwise. That broader understanding can then lead to a better, more insightful answer for your specific prompt. And sometimes it can even help reduce potential biases in the response.
The material used a video game storyline example. Can you walk through how step back worked there?
Sure. So, first try. A direct prompt asking for a storyline for a tough first-person shooter level. The output was okay, but maybe a bit generic. Then the step-back approach. First prompt. Based on popular FPS games, what are 5 fictional key settings for a challenging level? The model listed things like an abandoned military base, an underwater research facility. Finally, they went back to the original prompt, but added that list of settings as context. They asked the model to pick one theme from the list and write the storyline. The result, focusing on the underwater facility, was way more specific and engaging, showed the value of that initial step back.
Great example. Thinking broader first really helped to refine the specific answer. Okay, next up, chain of thought, or COT prompting. This one seems to get a lot of buzz.
Chain of thought, yeah, it's definitely a powerful one. Especially for boosting the reasoning chops of LLMs on tricky tasks, it works by telling the model explicitly, show your work, generate the intermediate reasoning steps before giving the final answer, and you can often make it even better by combining it with few-shot prompting, giving examples of the reasoning process you want.
So instead of just the answer from our sources, we ask it to basically think out loud, show the logic step by step. What are the big wins with using COT?
Several key benefits. It's usually pretty easy to implement, often just adding a phrase like, "let's think step by step" does the trick. It can make a surprising difference in accuracy on complex stuff, and often works right out of the box with standard LLMs, no fine-tuning needed. Plus, you get interpretability. You can actually follow the model's logic trail when it analyzes your sources, helps you see why it reached a conclusion, spot any weird reasoning, and it seems to make prompts more robust if you switch LLM versions.
Any downsides to watch out for?
Main one is just length. Including all that reasoning obviously makes the output longer, uses more tokens. That can mean higher costs with APIs, and maybe take a bit longer to process.
The material has a really clear math problem example showing the power of COT. Can you share that?
Absolutely. So, first, a direct question. When I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner? Without COT, the LM apparently got it wrong, said 63. Then they just added, "let's think step by step" to the prompt. With that simple change, the model correctly broke it down, calculated the age difference when the person was 3, partner was 9, so 6 years difference, then added that 6 years to the current age of 20. Correct answer, 26.
Wow, huge difference. Really shows how prompting for the reasoning steps can overcome limitations. And the material mentioned combining COT with one-shot or few-shot. How does that help?
By giving examples in the prompt where the answer includes the step-by-step reasoning, you basically show the model the format and logic you expect. It's like giving it a template to follow for new, similar problems related to your sources. Helps it structure its own thinking. Table 13 in the material shows single-shot Coty, giving one full question reasoning answer example before the actual target question.
Okay, so it sounds like if a task involves any kind of multi-step logic or problem solving with our information, Coty is definitely worth trying. The material points to a notebook for more Coty details. It says best practices are coming later. What's next after Coty?
Building on Coty, we have self-consistency. This aims to push reliability and accuracy even further, especially for tasks where there might be multiple ways to get to the right answer.
How does self-consistency improve on Coty?
Okay, so Coty often uses a more deterministic approach, right? Following one likely path. Self-consistency flips that. You run the same Coty prompt multiple times, but this time with a higher temperature setting. This encourages the model to explore different, potentially valid reasoning paths each time. Then you look at all the final answers it generated across those different paths and just pick the answer that shows up most often. Majority rules.
Ah, okay. So ask it to solve the problem several different ways using Coty, then take the most common answer. Makes sense for tasks where the logic isn't strictly linear based on our info. Sounds like it might be more computationally expensive, though.
It definitely is, yeah. Generating multiple responses takes more compute. But the payoff is it can give you a kind of confidence score. How likely is the most frequent answer to be correct? And it can really boost accuracy and coherence, especially for complex reasoning applied to your sources.
The material used an email classification example with some ambiguity. Sounds like a good test case.
Exactly. The email was friendly but mentioned a potential security bug, maybe with some sarcasm, making it tricky to definitively label important or not important. By running a zero-shot code prompt multiple times at a higher temperature, the model came up with different reasoning paths and different final classifications. Looking at how often each classification appeared gives you a more reliable take on the email's actual importance.
Okay, self-consistency. Use randomness to explore multiple copaths, then aggregate. Got it. Next up, tree of thoughts, or TOTI. The name suggests even more branching out than Coty.
You nailed it. Yeah, tree of thoughts basically generalizes Coty. Instead of just one linear chain, it lets the LLM explore multiple different reasoning paths at each step simultaneously. Imagine the model building a tree. Each thought is an intermediate step, and from each step, it can branch out to consider different possibilities or lines of reasoning. This is really good for super complex tasks related to your sources, things that might need a lot of exploration or trial and error to figure out.
Allows for much more flexible, deep problem solving.
Okay.
The material mentions a notebook for TOTI details too. What follows tree of thoughts?
After TOTI, we get to react. Stands for reason and act. This one's really cool. It's a paradigm that combines the LLM's language reasoning with the ability to use external tools and actually take actions based on its reasoning.
External tools. Like what kind of tools when we're analyzing our information?
Could be things like a search engine, right? To look up extra facts relevant to your sources, or maybe a code interpreter to run calculations based on data in your notes, or even APIs to pull data from other systems that connect to your analysis.
Wow, okay. So the LLM goes from just answering to actively doing things. How does this reason and act loop work?
It's iterative. The LLM first reasons about the problem or query related to your sources. It figures out a plan.
Yeah.
Then it performs an action from that plan, maybe runs a specific search query. It then observes the result of that action, takes that new info, updates its reasoning, maybe makes a new plan, and repeats. Reason, act, observe, reason, until it thinks it has the answer or has gathered what it needs.
Our material says seeing react really requires looking at code. It gives a Python example, LangChain, Vertex AI, Google search, asking about Metallica's kids.
Yeah, that's a good illustration. The code sets up a React agent. You give it the prompt, how many kids do the band members of Metallica have? And the terminal output shows the agent going through like 5 searches. First, it reasons, I need to know who's in Metallica. So it searches for that, finds the members. Then for each member, it reasons, I need to find out how many kids this person has, performs a search for each one. Finally, it reasons, okay, now I add up those numbers, sums them up, gets the answer, 10.
That's pretty powerful. The LLM actively gathering and piecing together information, not just relying on its training data. Sounds like setting up React might be more involved than just writing a text prompt, though.
Oh, definitely more involved. Like the material notes, you need to manage the history, keep sending back the previous prompts and results. You might need to trim that history too to stay within input limits. And you often need to give it initial examples or instructions to sort of bootstrap its reasoning and action process. There's a link to a notebook with a more detailed example showing the actual LLM inputs and outputs during the React process.
Okay, getting into sophisticated AI interactions here. Next, automatic prompt engineering, or APE, the idea of automating prompt creation. That's intriguing.
It is, isn't it? APE. The core idea. Use language models to help you find better prompts. It's kind of meta. The general method is you prompt one LLM to generate a bunch of different potential prompts for your task. Then you automatically evaluate how good those generated prompts are. Maybe refine the promising ones, repeat.
Can you give a concrete example? Maybe related to understanding our sources.
Okay, imagine you're building a Q&A system for a pile of documents you have. You want the best prompt to get accurate answers from that content. Using APE, you could start by prompting an LLM. Generate 10 different phrasings for a prompt that asks for a concise answer based on a provided document. It might spit out things like, summarize the key findings, what are the main conclusions, extract the most important info, etc. Then you test how well each of those prompts actually performs on your documents. Maybe use automated metrics, maybe human review. Pick the winners, maybe tweak them, try again.
So using the AI to brainstorm ways to ask it things, then testing those phrasings on our actual material, how does that evaluation part work? What kind of metrics?
Depends on the task. For Q&A, you might compare the generated answer to a known good answer using metrics like BLAU or Rouge. For summarization, maybe metrics assessing fluency or relevance, or, like I said, just human judgment. Based on those scores or reviews, you pick the best performing prompts.
Really interesting way to leverage the AI itself to optimize interaction. Okay, let's shift gears a bit. Code prompting. The material says Gemini is text-focused, but that includes code.
Yes, Gemini's quite capable with code various languages, and Vertex AI Studio is a good place to try these code-related prompts out.
The material shows examples for writing, explaining, translating, even debugging code. Let's start with writing code. How's that helpful when analyzing information?
Well, imagine you're looking at some data in your sources and you realize, hey, I need a quick script to clean this up, or I need to extract these specific bits automatically. Instead of writing it yourself, you could just describe what you need in a prompt to Gemini. Table 16 shows asking for a bash script to rename files in a folder, adding draft to the start of each name, and boom, out comes a documented bash script.
That could be a huge time saver if you deal with data or files mentioned in your sources. But there's a warning about LLM-generated code, right?
Crucial warning, yeah. LLMs generate code based on patterns they've seen. They don't reason about code like a human developer does. So you absolutely must review and thoroughly test any code an LLM gives you before you rely on it, especially in anything important. The material even shows the steps for testing that bash script to make sure it actually works correctly.
Okay, review and test.
Yeah.
Got it. What about explaining code? Useful if we find code snippets in our research notes we don't quite get.
Exactly. You can just paste a code snippet into the prompt and ask Gemini to explain it. Table 17 takes that bash script, strips out the comments, and asks for an explanation. And the output clearly breaks down what each part of the script is doing. Fantastic for understanding unfamiliar code or quickly grasping the logic of something you found in your sources.
Like instant code comments. What about translating code between languages?
Another big efficiency booster. Maybe you found a useful script in your research, but it's in a language you don't use and you need to integrate it. LLMs like Gemini can often do a decent job translating. Table 18 shows translating that bash file renaming script into Python. Again, the caveat applies. Review and test the translated code thoroughly. Oh, and the material mentions a useful tip for Python in Language Studio. Hit the markdown button to make sure the indentation comes out right. Super important for Python.
Good tip. Finally, debugging and reviewing code. Sounds like the LLM can be a coding buddy.
It really can be. The example here is neat. They took the translated Python code, deliberately broke it by introducing an error, then fed the broken code and the error message, the traceback, to Gemini. The prompt asked it to debug and suggest improvements. And the LLM, it nailed the name error, suggested the correct fix.upper method, and went further. It suggested handling file extensions better, dealing with spaces in file names, using f-strings, adding error handling with try.accept, just generally making the code more robust.
Wow, that's more than just fixing the bug. It's offering proactive improvements. The material even notes the response got cut off by the token limit, suggesting more feedback might have come with a higher limit. Seems LLMs can be real collaborators for coding tasks arising from analysis. Now, brief mention. What about multimodal prompting? What's that?
Right, so the code prompting we just discussed still uses text prompts, treating code as text. Multimodal prompting goes further. It means using multiple types of input in your prompt, maybe text combined with images or audio or other data formats, depending on what the specific LLM can handle. Opens up richer ways to interact with and analyze information beyond just text.
Fascinating possibilities there. Okay, this has been a fantastic tour of techniques. Let's pivot now to the really crucial best practices. Actionable advice we can use right away with our own info.
Absolutely. And like we've said, finding the perfect prompt often takes some trial and error. Tools like Language Studio and Vertex AI are great sandboxes for that experimentation.
So what's best practice number one?
Provide examples. Use one-shot or few-shot prompting. It's just such an effective way to teach the model. Show it what you want or show it examples of good responses you've seen. Massively improves accuracy, style, tone, especially when dealing with your specific sources.
Showing beats telling. Makes sense. What's another key practice?
Keep it simple. Design your prompts to be clear, concise, easy to understand for you and the model. Avoid convoluted language, unnecessary jargon. The material had that before or after for a New York travel guide prompt. Simplifying it, using direct action verbs, made it much more focused and useful.
Simplicity, clarity. Got it. Next.
Be specific about the output you want. Concise is good, but sometimes too general. Give details. Use system or contextual prompting, like we discussed, to help the model really zero in. The do versus do not examples for the video game console blog post showed that. Being specific about what to include gets better results than being vague.
Specificity helps the model meet our needs. What about how we ask? Instructions versus constraints.
Yeah, this is interesting. Research suggests focusing on positive instructions, telling the model what to do, often works better than loading it up with constraints, telling it what not to do. Instructions clearly state the goal. Constraints can be limiting, make the model guess. Now, constraints definitely have their place, right? Preventing harmful stuff, enforcing strict formats like JSON. But the general advice: prioritize clear instructions. Use constraints strategically when needed. The material had examples for that top consoles blog post, what to include versus what to avoid. Beth bet. Experiment with combinations, document what happens.
Helpful distinction. Instructions first, constraints second. What else?
Control the max token length, always. Either in the config settings or explicitly in the prompt, like asking for a tweet length explanation or 3 key bullet points. Also, use variables in prompts, especially if you're reusing a prompt structure with different inputs from your sources, like swapping out city names in a travel prompt. Table 20 showed that. Makes prompts dynamic, easier to manage, great for integrating into apps.
Variables for reuse. Smart. What about trying different ways to phrase things?
Definitely experiment. Try different input formats, different writing styles. Ask a question versus making a statement versus giving a direct command. You might get surprisingly different results for the same basic request about your sources. Play with word choice, overall style. The material showed phrasing a prompt about the Sega Dreamcast 3 ways: question, statement, instruction. Each might give a slightly different output flavor.
Worth trying different angles of stuck. Okay, specific tip for few-shot prompting with classification tasks.
Right. When using few-shot for classification based on your info, good idea to mix up the order of the classes in your examples. While order doesn't always matter hugely, mixing them helps prevent the model just learning a superficial pattern based on the order. It forces it to actually learn the features of each class. Leads to more robust classification. Starting with maybe 6 examples is often suggested for classification.
Subtle but smart for classification reliability. What about keeping up with the models themselves?
Adapt to model updates. This field moves fast. New models, new capabilities all the time. Stay aware, try out newer versions when they arrive, adjust your prompts. Again, tools like Vertex AI Studio are great here. Lets you save prompt versions, test them against different model versions easily.
It's an ongoing learning curve then. What about the output format we asked for?
Experiment, especially for non-creative tasks like data extraction or parsing from your sources. Try asking for structured formats, JSON or XML. JSON especially has loads of benefits. Consistent style, focuses on the data you want, less chance of random hallucinated stuff, understands relationships, handles data types, makes sorting easy. Table 4 showed getting JSON output earlier.
JSON sounds super useful for structured analysis. But the material mentioned JSON repair. Why would we need that?
Yeah. JSON is great, but sometimes it can be verbose. Longer response means higher chance of hitting the token limit and getting cut off. Truncated JSON is often invalid, missing closing brackets, braces, makes it impossible to parse. Luckily, there are libraries like JSON Repair that can often automatically fix that broken JSON. Saves you a lot of hassle.
Handy tool. And there was also working with schemas. How does providing a schema help?
Okay, so we talked about getting JSON output. You can also use JSON schemas to define the structure of JSON input you give the model in the prompt. It's like giving the model a blueprint for the data it's about to see. What fields to expect, what data types. Really helpful when dealing with structured info in your sources. Reduces misinterpretation, focuses the model, clarifies relationships, can even make it aware of time if you use date formats. The material had a simple product schema example, snippet 5, and some matching data, snippet 6. Giving schema plus data instead of just raw text gives the LLM a clear understanding, especially useful with complex data.
Schemas for structured input clarity. Got it. What about working with others?
Experiment together. If you're stuck on a prompt for your sources, team up. Different people often come up with surprisingly different, effective prompts, even following the same best practices. Share approaches, share results, faster progress.
Teamwork makes the dream work. Okay, some specific best practices for chain of thought. Key takeaways for QT.
Right, QT specifics. First, generally, the final answer needs to come after the reasoning steps in the output. Lets the logic build naturally. If you're using QT with self-consistency, make sure you can easily pull out just the final answer from each reasoning chain. And super important, for standard QT, where you want logical reasoning towards usually one right answer from your sources. Always set the temperature to 0. Minimize randomness. Force it down the most probable logical path.
The PSIWA QT makes total sense for logical tasks. Finally, the last best practice, documentation. Can't stress this enough, can we?
Absolutely not. Documenting your prompt attempts is just critical. Keep detailed records. What was the goal with your sources? Which model, version, all the settings, temp, tokens, etc. The exact prompt text, the output. Was it okay? Not okay. Sometimes okay, your feedback. The material even suggests a Google Sheet template, Table 21. This log is invaluable later for revisiting, testing on new models, debugging. If you use Vertex AI Studio, save the prompts there, link them in your docs. If you're doing complex stuff like RUG, document the retrieval part too. Once a prompt is good, save it properly in your code base. Maybe add automated tests. Remember, prompt engineering is iterative. Craft, test, analyze, refine, and re-experiment when models change.
Wow, okay. This has been an incredibly thorough, really insightful deep dive into prompt engineering. We've covered so much ground. Fundamentals, all those techniques, configuration, and these crucial best practices.
Yeah, and hopefully mastering these techniques, following these practices, will really help everyone listening unlock the full power of these LLMs for analyzing their own sources, whether it's quick info extraction, complex problem solving, or even generating code.
So the clear next step for you, our listener, is to just start experimenting.
Okay.
Grab your own stack of information, try these techniques. Remember, it's iterative, don't get discouraged, and definitely document what you find.
Right. And maybe a final thought to chew on as you get better at guiding AI through language. This ability to precisely communicate with these models, it's more than just a tech skill. It's really a new form of communication, isn't it? A new way to elicit knowledge. What does that mean for how we learn, how we work, how we interact with information going forward? Something really transformative to think about.